Okay, so the correct answer for that one, 0.717 grams, and we saw some variation due to significant figures. Now, we can also use standard molar volume as a conversion factor if we have gases. And we can combine this with molar mass and mole-to-mole ratios. And later on, you're going to see we can use molarity as mole-to-liter ratios. So we can use any of these ratios we've introduced up until this point. So our standard molar volume, remember, is 1 mole of gas is 22.414 liters at STP. So this only works at STP. At other temperatures, we have different ratios that we'll talk about in the very last part of segment 5. But we can use this now to combine information when we're dealing with gas. Let's look at this example. This is an everyday thing you know. How many of you drive a vehicle with an airbag? Yeah, none of you really, because it's not really an airbag, it's a nitrogen bag, right? Because that's generated with sodium azide. Sodium azide is a shock-sensitive compound. I think this is really cool technology. So you've got this shock-sensitive compound, and you drive your car into a unmovable object, like the concrete abutment, right? And your airbag goes off. Well, I mean, has anyone ever demonstrated this? Anybody ever had an airbag go off on them? Oh, yeah. Do you have any recollection of the incident? Yeah, that was awesome, huh? Did you have burns later on your face and arms? Yeah, it's pretty intense. Oh. So this produces nitrogen gas. It doesn't produce air. It produces nitrogen gas. So it's a nitrogen bag, not an airbag. And sodium metal. Now, if we balance this equation, we have a 2, 2, and a 3. So this is really cool technology. We can make nitrogen gas and cushion you so that you don't go flying through the windshield. But remember when we talked about the alkali metals? This isn't about solving this problem. This is about airbags. We talked about the alkali metals, and what do you remember about sodium metal when we threw it in water? It's very reactive, right? And it produces hydrogen gas, and it made a basic solution. It produced sodium hydroxide. Sodium hydroxide is drain cleaner and oven cleaner at home. So now think about this. You just crashed your car, and you've got little flecks of sodium metal floating around from this chemistry that's happening right in front of your face. And you've got moisture in the air. That sodium metal reacts instantly with the moisture in the air, and it makes sodium hydroxide. So now you have just been hit in the face with this rough bag. You've got crushed steel all around you, or fiberglass if you're driving your vet that day. And you now have sodium hydroxide, drain cleaner, oven cleaner, all over you. So, if you wreck your car and the airbag goes off, as soon as you can, get to a shower. Okay? Seriously. You want to go home and shower or get to a sink and wash off your face and your neck and your arms because it can cause serious burns. I have some photographs of that. I'll show you if I can dig them out when you're doing the next problem. But my son deployed an airbag in his pickup truck. He was involved in a head-on collision. Thankfully, no one was injured. All the airbags went off, side airbags and everything. And nobody got hurt, so that was really lucky. But then he told me later that his arm was really bothering him. I'm like, oh, did it get burned? And he's like, yeah, how'd you know that? And I said, because I'm your mother and I'm smart. I know these things. And I'm a chemist. But he actually sent me some really cool photos of the damage that the airbag did to his arm, the burns he got from it. So always go home and wash that off. Okay, that's an aside to the problem. So if the airbag contains 100 grams of sodium azide, 65 grams per mole, What's the volume of nitrogen gas at STP? So we want our answer with volume, so we need that liters. So we know we have the 22.4 liters per 1 mole of nitrogen. We have our molar mass in grams, and we have 100 grams of sodium azide. So we want our answer in volume of nitrogen. Where do I start? With my 22.4 liters, so I get liters on top, right? So 22.4 liters of nitrogen per 1 mole of nitrogen. Now, to cancel out the moles of nitrogen, where do I go? Molar mass or to the equation? To the equation, because do I want grams of nitrogen in here? No, I don't have anything else with grams of nitrogen, so I go to the equation. The equation is always going to be our second step, okay? So I have 3 moles of nitrogen for 2 moles of sodium azide, because I'm comparing nitrogen and sodium azide. So now I've canceled my moles of nitrogen. Now I need to get rid of moles of sodium azide. So 1 mole of sodium azide is 65.02 grams of sodium azide. My moles cancel, and I have 100 grams of sodium azide. So I get 51.7 liters of nitrogen. That's a lot of nitrogen. Okay, that's a lot of nitrogen being produced. 100 grams. I can hold 100 grams in my hand easily. It's not that much, right? But now think about driving around with that in your car. And more than that, how many of you have cars with side airbags? Anybody? Yeah, so you've got 2 sides, front seat, and then the one in the steering wheel and one in the passenger's front seat usually. So you got 4 of these little detonators in there. All right, let's go ahead and have you do the next one.